we're able to do the first two questions just like the normal rational function, similar to those, and then they are going to be similar to these questions. If you're struggling with these are the type of questions that are going to be on there. That just means you need to kind of study these a little more. Okay, so I want us to kind of think about these questions. So I'm going to read this real quick. So it says, Joey and Natasha start from the same point and they walk in the same direction. Joey walks 2 kilometers per hour faster than Natasha, and after 3 hours, they are 30 kilometers apart. How fast did each walk? So when I think about this, they're walking in different directions, right? Oh, it should be Joey. Sorry. So Joey is walking this way, and Natasha is walking this way. Right? They're going farther and farther apart until finally they walk a total of 30 kilometers, right? So we know that eventually they reach a point of 30 kilometers. We know that it takes them, it takes them 3 hours, so it takes them 3 hours. We also know that Joey walks 2 kilometers per hour faster, so we know he walks as fast as Natasha, but he walks a little faster, so again, he would walk just as fast as Natasha, but just a little faster. It says he walks 2 kilometers faster, and Natasha walks just as fast as herself. So there are 2 ideas behind this, and if you think about this, they're actually walking in a sense like their rates are together. So what that means is that they're actually both creating the 30 kilometers at the same time. So in a way, they're combining their rates. So we know that the distance is equal to rate times time. Well, both of them, if you add up their rates together, that is equal to the total distance. So the distance is actually equal to how fast Joey is going for 3 hours plus how fast Natasha is going for 3 hours. So Natasha is going for 3 hours, and because they're traveling the same amount of distance, or they're not traveling the same distance, but they're covering a common area, then we can add the rates together. The reason is we can combine their rates, right? Because in a sense, they are working together to cover 30 kilometers, right? So in this scenario, you want to think, oh, if they're covering the same area and they're creating the same amount of space and they're moving in opposite directions, we can add their rates together, right? Because in a sense, it's going faster because they're traveling in different directions. So we know the distance is 30 kilometers, and then we just multiply 3n plus 6 plus 3n, and we get 30 is equal to 6n plus 6. We minus 6 on both sides, and really this part is the easier part where you just solve for n. You get 6n is equal to 24. Divide by 6 on both sides, n is equal to 4. So the hard part, I'd say, for these questions is knowing how to set these up, right? The hard part about these questions is, how do I set this up? Again, for this scenario, the reason we knew to add their rates together is because they're moving in opposite directions. And so because they're moving in opposite directions, we want to combine their rates because they're both covering the 30 kilometers per second. Okay, does anyone have any questions about this one? So again, this one, because they're covering the same area and they're moving away from each other, the rates add on to each other, right? The rates add on to each other. Okay, so if I flip to the backhand side, I'm not going to solve this one. I'm just going to set it up. But I do want to think about this. So it says Nick and Chloe leave their campsite by canoe and paddle downstream at an average rate of 12 kilometers per hour. They turned around and paddled back upstream at an average rate of 4 kilometers per hour, and the total trip took 1 hour. After how much time did the campers turn around downstream? So at this point, you should already have a clue of which one to figure out. So this one, what you know is that the time that they took to travel downstream, the distance is exactly the same that they covered going upstream. So what I mean is that they traveled downstream at 12 kilometers per hour. And they also traveled upstream at 4 kilometers per hour. Right? What we know, which is really important, is that the distance they covered going downstream and upstream is exactly the same, right? It's exactly the same. So the time that they went downstream, maybe they went somewhere and then they stopped and they're like, okay, it's time to go back. And so they traveled upstream. Well, that distance they traveled is exactly the same. One's just faster than the other. So that means at this point you go, okay, since the distance they covered going down is the same as the distance going up, we can understand and set those two equal to each other. So just as a reminder, that distance is equal to rate times time. So that means the rate of them going down, they traveled for 12 kilometers. So they traveled for 12 kilometers, and we know that it took them a certain amount of time. We don't know how much time it took them. So we're just going to call that T. We know that is equal to the distance that they traveled downstream. Well, that is equal to the distance, right? And we know the distance is equal to, so this is equal to the distance. We also know that the distance is also equal to the rate they took going upstream. And we know the total time it took them was 1 hour. So we know that whatever remaining time, well, the time they took going downstream, it's just going to be 1 hour minus the time they took going downstream. So the rest of the time they spent going upstream, they covered the same distance. Since both of these equal the same distance, we could just set them equal to each other. So we do 12t is equal to 4 times 1 minus t, and then you just solve, because now the hardest part again is creating the equation itself.
Well, because T, so 2 hours, for Sally it's 80 kilometers an hour times 2 hours, and for Terry it's 20 kilometers an hour times 8 hours.
So for this one, the big clue for you is to understand that the distance that they covered was exactly the same. So when they covered going downstream versus upstream, they have different speeds, but they covered the same distance. So once you understand that they covered the same distance, you want to find the rate in time equals the other rate in time. That's how we know to use this and set up the equation. Okay, so the big clue again is that they covered the same distance going downstream as they covered going upstream. And that's how we know to equal the same thing. Okay, if we look at the next one, so again, you could solve and eventually get an answer. I will post these answers online. It says Terry leaves his house riding a bike at 20 kilometers per hour. Sally leaves 6 hours later on a scooter to catch up with him traveling at 80 kilometers per hour. How long will it take her to catch up with him? Okay, so now I want you to think about, well, how does this relate to distance equals rate times time? Everything, all these problems are related to distance equals rate times time. There are some work problems, but all of these are distance problems. And I will try to cover some work problems. So this one, a big clue in is that they're asking how long will it take for her to catch up with him. Okay, so the big clue is actually in the question itself. How long will it take for her to catch up with him? So in this one, we should know that something is the same for both of them. What is the same for both of them, Dan?
The distance traveled.
Right, the distance traveled, because when she catches up with Terry, they're going to have traveled the same exact distance. So we want to set up two distance equations and then set them equal to each other. So we know the distance traveled for Terry, he leaves his house at 20 kilometers per second, right? So he's going about, divide by 5 times by 3.2. He's going about 12 miles per hour-ish. 12.6. And we know that he leaves for some time, right? He leaves for some time. So he travels for T amount of time. We don't actually know how long. We just know it's T amount of time. We know that Sally, she travels the same distance because that's when she catches up to him. They've traveled the same amount. And we know that she's traveling at 80 kilometers per second, which is about 48 miles per hour. It's kind of incredible. We don't know how much time she's going to spend, but we do know she's going to leave 6 hours later. So she's going to travel the same amount of time as Terry minus 6 hours because she's traveling 6 hours later, right? So we know that she's leaving at T minus 6. And the reason I'm setting up like this, again, remember, is distance is equal to rate times time. So Terry, this is Terry right here, and then this is Sally. Terry is traveling at 20 kilometers per hour for T amount of hours, right? We don't know how long. That's what we're going to solve for. We know that Sally is going to travel for 80 kilometers per hour for however long Terry traveled minus 6 because she's leaving 6 hours later or 6 hours less than Terry. Well, since she's going to catch up with him, they're going to travel the same distance, so we can set them equal to each other. We know Terry's distance is equal to Sally's distance. And then you can see here we've set up our equation. That's the hard part, is setting it up, and now we can just solve, right? Now you can 80 times t, which is 80t, 80 times negative 6, that's negative 480, and then you just solve for t, and then that's it. For this one, I'm actually going to solve it just so you can see, just to be careful how you answer, because the answer is kind of important too. So we have 20t is equal to 80t minus 480. And then I add 480 to both sides. I'm just trying to get the constants by themselves. I'm going to minus 20t. So I get 480 is equal to 60t. Divide by 60 on both sides, and I get t is equal to 8. So I don't want you to go, okay, t is equal to 8, that's my answer, box it. What we see here, t, remember, represents the time that Terry traveled, right? But they're asking us how long will it take for her to catch up with him? Well, Terry's been traveling for 8 hours, but Sally traveled 6 hours after. So that means the time that Sally traveled is 8 minus 6, which is 2 hours, right? It's 2 hours. So you want to answer this question, which is how long will it take for her to catch up with him? It takes Sally 2 hours. That's fine. You can have different equations. So you can see here that Terry traveled for 8 hours, but Sally traveled 6 hours after that. So that's 8 minus 6, which is 2, right? 2 hours. So again, here, the big clue, the reason we knew how to set up this equation was because Sally catches up with Terry, so they travel the same distance. They travel the same distance.
Rate times time.
Okay, are there any questions on number 3? Any questions on number 3? Okay, so I'm going to look at the last one right here. It says, on a 130 kilometer trip, a car traveled at an average speed of 55 kilometers per hour, and then it reduced its speed to 40 kilometers per hour for the remainder of the trip. The trip took 2.5 hours. How long did the car travel for 40 kilometers per hour?
1 hour.
Oh, you guys are going to see.
Wait, no, I got the answer wrong.
Well, we still got the minutes. So this one, you want to think about the distance. So we know they covered the same amount of ground again. Part of it was the first parts. So for this one, you could see that they traveled for 130 miles, and then you would add the rates together here because a certain amount of time they traveled at 55 t, and another certain amount of time they traveled for 40 kilometers per hour. So you would just say one of the formulas is 55 times t, that's one of the rates. The other rate is 40 times 2.5 minus t. And we know that they covered a total of ground of 130 was at 55t plus 40 times 2.5 minus t. So the reason we know this is because they traveled at 55 miles per or kilometers per hour for a certain amount of time, and then after a while they traveled for 40 kilometers per hour for the remainder of the time, which is 2.5 minus t.
I made such a dumb mistake.
So then the easy part now is just solving it. You add them, you multiply, you add them together, and then you solve. That's it. And again,